Hi, my name is Manish Karir. I work at Merit Networks. Today I'll be talking about a problem that has been coming up as sort of an undertone to a lot of discussions in the hallways and at the meeting here over the past couple of years at least. Essentially, the problem that I'm going to talk about is how do we go about improving the accuracy of data in the routing registry, such as RADB. So roughly what I'm going to talk about is I'm going to talk about an ongoing project that we have that's attempting to rebuild the RADB, at least the client side of things, not a whole lot of changes on the server end, but at least the client interface to provide a whole lot of more information to the users so that they have more information available to them to keep their route objects up to date. And in particular, what we're doing is including both route object checks which are internal to the registry, as well as providing a link with a live internet route feed. So once again, we're providing this link which has always been missing, which is you have registered route objects on one hand, and then the actual information that gets routed on the internet on the other hand, and the two are never linked or never put together in the same place. And what we're hoping is by making this link, people will have this information where they can update their objects and keep them up to date. And it's basically the motivation which we're providing them. If you provide this motivation, you get better feedback and you have better control of what you're doing. So some quick background information about the RADB. It's based on the IRD software, which is available for free download, but the RADB service is more than that. What we're doing with the routing registry is make prefix policy information publicly available to the internet community. The registered objects are in RPSL format, which is a standard format. And these days, or up till now, the process of using the RADB has been you create a maintainer account and you go register your route objects as a two-step process. And then if you need to do updates to them, you send email to a specific email address with the right format, and it updates your route objects. Or you can go through a website and update your route objects that way. The big drawbacks with this whole process up till now has been there was no feedback to the user during the whole process other than simple error checking on your syntax is not right. And the other problem up till now has been that there was no relationship between what you registered and what was actually being routed on the internet. So we've started the RADB-ng project at Merit, and what it does is it essentially provides a portal-based route object maintenance framework. And what you do when you have a portal-based system is you minimize the information that the user sees to specifically the objects that they've registered. And you make it easy for them to add, delete, and modify registry objects. You make it easy for them to examine what they have registered. And you provide quick summary information so that they have a rough idea of how they are using the RADB. And we also provide feedback on inconsistencies that we observe. So what are some of the internal consistency checks that we perform? Here's two examples of what we've implemented so far. We do consistency checks, where we generate lists of all route objects that do not have a matching OTnum object. And then we'll make a recommendation through a drop-down list saying, hey, you don't have a corresponding object which we think you should have, and would you like to add it now? Another example of an internal consistency check that we do is we generate lists of all prefixes that have multiple route objects. Now, this may be something that you intended, but more than likely you probably didn't. And we give the user the option of going ahead and deleting the redundant route object. So once again, you can keep your information up to date. The second type of consistency checks that we perform are with the live internet routing feed. And here's an example of the sort of things we look for. For example, we generate lists of all the announced routes for your registered autonomous systems. We generate lists of all unregistered routes. Basically, these are routes that were seen in the route table, but you do not have a corresponding route object for. This is one of the main advantages of the portal-based system is we have a very good idea of what your specific information is. And then when we go do these comparisons, the results we're generating back are for your specific account. Another example is we generate lists of all the announced route objects. So, I registered 200 objects, and here's a list of all the ones that are actually being announced right now. And So, if there's any inconsistency there, you can go back and correct your BGP feed, or you can go back and update your RADB objects. And we also generate lists of unannounced objects, just in case that was not your intent. You would have the information there to modify that information. And lastly, one of the important checks we've also added is the alerting system, which looks at the update messages as they're coming in on a BGP feed and does origin AS checks and feeds this information back to the RADB portal, and you can quickly see any prefix hijacks or misconfigurations that you might have done. So let me provide a quick example of what the new interface looks like. Right now we're looking at the object information page. This is the first thing that you see when you log in. On the top, you have summary information. It lists all the route objects that are registered for your maintainer ID, providing summary counts. On the bottom left, we have drop-down lists, which are prefix lists, essentially, of all. These are the drop-down lists which let you select which object you would like to see the information for. And then finally, on the right, you will see details of what you've selected to view. And you have a button right there to edit or delete this information. The second tab is the consistency check. Once again, on the left, we see a summary table, which is a breakdown per AS object that you have registered of what are the announced routes, unannounced routes, announced objects, broken down by AS numbers. On the top, again, you have the drop-down list, which lists each of these entries, so you can select which one you want to view the detailed information of. Things like multiple entries, missing APNIC objects, unregistered routes. The drop-down list will let you select which one of these you want to view more information on. And finally, on the bottom right, you will actually see the exact object as it's registered in the RADB, and you have the option of editing, deleting, or adding information. And finally, the alerting, which is the feedback coming from a live update, BGP update feed. And what you're seeing over here is on the top left, you see alerts where for your prefixes, the AS in the routing table was different from the AS that was registered in the RADB. And then you will also see a table that lists what might be apparent misconfigurations on your part, where you're announcing some prefixes, but in the routing table they're showing up as belonging to somebody else, or in the RADB they're shown as belonging to somebody else. So finally, a quick summary. What we've developed is an integrated framework that provides an easy-to-use interface to keep routing registry data up to date. It includes feedback from various consistency checks. And what we've actually done here is try to build the missing link between live internet routing data and the RADB. And if we're currently in beta test. We're hoping to have this go live by the end of the month. And if you'd like a test account, please send me an email.
Any questions? Okay, thanks.